Okay. Oh, so kind of before the days of COVID, I would take attendance in this class because I found out that when I started recording my videos, recording my lectures and making them available, that class went better, because if your only chance to kind of follow along was right here in class and you got behind and be like, oh, stop, can you hold on and help? And now that everyone knows that they're being recorded, I thought that's great, because they can go back and watch it later. If they get a little bit behind, you think, okay, I'll just pay attention in class and maybe go work the example later. But then attendance really dropped. It was like there was like 6 people in class and everyone was watching the videos on double time or whatever. So the university has kind of actually since made a policy on this that I'm not really allowed to tell you can take the class without coming to class, unless I go through a whole different approval process with them. But the whole point is that I used to take attendance to help get people here. I'm not going to take attendance. It's not going to affect your grade at all. But the way I used to take attendance was by putting up a quote from the founding of our country. And we'd tell a little story about it. And then you would kind of go to a website and you'd put the author who spoke the quote and the year and your net ID. And that's how I would know you were here. But it turns out that, like in my course evaluations, people are like, look, we loved VBA, but the best part of the class was talking about history for a couple of minutes at the beginning of each class and the founding of the nation. So I'm going to go ahead and do that, even though it's not, there's no mechanism here for doing attendance. So this is a quote that from George Washington. It was actually in a letter written to his mother after the defeat of Braddock. In 1755, we have the French Indian War going on. It's not going so well for the British, going pretty good for the French and Indians. And in fact, this is really the first major engagement, Braddock's defeat. So once the British get serious about kicking the French out of what they claim as their territory in North America, they bring in Edward Braddock, old school military European general, who believes that if you've got superiority of firepower and superiority of numbers, you're virtually guaranteed victory in battle. So by this time, George Washington, 1755, George Washington thinks his military career is over. He's settled in to be a gentleman farmer for the rest of his life. But when Braddock shows up, he says, Braddock's a pretty popular guy, and the chance to kind of get connected with him and work closely with him could be really good for my social standing. And so he decides to go ahead and sign up to fight with Braddock. Now, Washington was actually a colonel in the Virginia regiment. He is now commissioned as a captain in the British Army. So I don't know, do we have anyone here with the kind of military? Is that a substantial reduction in rank to go from colonel to captain? Anyone know? Yeah, that's huge. Yeah, that's huge. Okay, so Washington does it, and is kind of in the council of folks that kind of have Braddock's ear. And he tells Braddock, he says, look, here in North America, you really got to pay attention to the geography. Braddock dismisses it. Anyway, he takes 2,000 men and just a huge amount of firepower, and they are going from Virginia to Pittsburgh. Now, today you think Pittsburgh, let them have it. But Pittsburgh is right where the Allegheny and Monongahela rivers meet to form the Ohio River. It is like the major crossroads in that part of the country. And so it's critically important to control that. So they're headed there. They get within 30 miles of it. 1,800 men are there are about 200 men that are a little further back. 1,800 men are kind of headed in about 30 miles from Pittsburgh. They're surrounded by French and Indians. And what happens next is nothing short of a massacre. So we have Braddock himself is wounded mortally wounded in the first 5 minutes of the fighting. One by one, the other officers fall, and Washington, as a captain, finds himself as the ranking military officer over what stands to this day as the worst defeat in British military history. Of the 1,800 men that went out, 400 British would come out alive. And every one of them owed their lives to George Washington, who effected an orderly retreat. This is really the beginning of the mythology around George Washington. In this battle, he will have 2 horses shot out from under him. He will have 4 bullet holes in his coat, but he won't be scratched in the battle. And in fact, years later, when George Washington is president of the United States, Indians who are at this battle will come to visit him in New York, the capital of the newly formed United States of America. They will come to New York to pay homage to the man who had the protection of the Great Spirit. So it's not just this kind of mythology around Washington that's British American mythology, but generally American kind of American mythology here. So anyway, after this event, which of course shapes him for the rest of his life, he writes this to his mother, and in this letter to his mother, he says, "God's hand was on me, God protected me and kept me through the battle." So this kind of brings us to one of the things that, kind of an idea that made Americans who they were at the founding of our nation. And this is the belief, kind of the shared belief in a God who is concerned with the affairs of nations and intervenes in the lives of men. It's the term that they used at the time was divine providence. And it's something that we've lost. It's part of kind of what used to make us Americans that we no longer unite around as a country. And that's kind of what we'll be talking about. It's kind of several of those values that I think are lost, and I'm hoping to be able to help bring back to our nation. All right, before we get started on the content for today, I think I have some TAs here. We could just have whatever TAs we have here. If you just kind of stand up and maybe take your mask off so folks can see you, and just say who you are and say, "Hi, I'm a TA." Excellent.
I'm Adam. I'm also one of the TAs.
And our other TA, so we're 4 TAs, our other TA, Matthew, who's actually the lead TA, is like at a funeral or something. So I expect he'll be in next week. Thanks for coming. You're more than welcome to stay in class today. It's going to be mostly a conceptual day, so I don't think we'll need much help in terms of helping people on the computers today. All right. Hey, listen, before we get into today's content, why don't we go through the process of, what does it actually take to do a homework assignment? Why don't we just do I think we have homework due for next Monday. Is that right? Should we just do that homework assignment right now? It's really easy. It's really easy if you've got someone showing you how to do it. So I get that may be true well, that's probably not true for all homework assignments. Okay. So I got to figure out where is the assignment. So create a web query. Oh, hey, TAs, have you left yet? Oh, almost. I got to get these updated. I hope this is actually, whoops, that's a YouTube. I don't want to go to YouTube. Go back. Create a web query. Did I even update this to the right? I'm not entirely sure I updated this to the right book, fall 2021. That's no good. Anyway, we got to get to create. I'm going to update those. I'm going to have my TAs update those links. But we need to find in our course, create a web query assignment. So let me get to our course. Which should be right here. Winter 2022, that looks better. You've got a menu up here that says course. You can choose where it says course and go to assessments. And we should be able to find that assessment. Create a web query. So this is the one that we're after. And this is going to be the way that these homework assignments go. You're going to download a workbook. You'll open it up, and that's where you'll really find the detailed instructions for the assignment. Okay, so now we also have to have the Atlas add-in showing. So there should be an Atlas tab up here. So just for a review, let's go back to Learning Suite and remember that we're downloading that from right here, the Atlas VBA 1.5. I think I've already downloaded that. But once we get that downloaded, I'm going to go ahead and install it. Oh, actually, someone showed me there's a quick way to get there. Is it on developer? Yeah, on the developer tab, we can come straight to Excel add-ins right here. So developer add-ins, and then I'm going to find that. I think I have to uncheck it. I'm not sure why it's not showing, but I'm going to uncheck it, click add-ins again, check the Atlas one. Might have to browse if you just downloaded it, you'll have to browse and go find the file, then check it, and it should show up. There we go. So I've got the homework assignment file open and I've got the Atlas add-in. Then I should be able to click on show instruction sheet, and that should bring up the detailed instructions for the assignment. So here's the assignment: create a web query, 10 points. And so this is going to tell us what we're going through. So using the tool, Anyway, so we're going to use the legacy web query. It turns out that, when was it? Around 2017 or so? Forever, like since the early 2000s, they had this tool called the Web Query Wizard. And they kind of let it slide, didn't really update it. And then in 2017, they replaced it with a new one, but the old one is still around. And it turns out the VBA code that gets recorded when we use the old legacy Web Query Wizard is much easier to work with than the new one. And so in terms of kind of beginning here in the class, we're going to start off with this older one just because it writes simpler VBA code for us. But what we're doing in this example here, in this homework assignment, there's no VBA involved here. All this homework assignment is make a web query. That's it. Because we're going to be using that web query tool in class next time we're together. So the idea here is that you've gone through this before you come to class and you already have some exposure to what a web query is. So let's go ahead and do it. So it says use the legacy web query wizard and bring in a quote from here. Let me go ahead and just copy that. As we're doing. Okay, so here's how we find the legacy web query wizard. So it's not really available through the menu choice anymore. If I come through data and I can say from web, this is the new one. That makes sense. That's the one that's there. But if I search, tell me what you want me to do. I'm just going to say web here. And that should bring in from web. Well, I should see from web legacy. That's the one that I'm after. So this is going to open up a little browser. It's actually using Internet Explorer. And even when Internet Explorer was kind of still active, this was kind of a really crippled version of Internet Explorer. Didn't really do a great job. And you'll, depending on what your home page is, you may actually see like errors come up. And if that's the case, just click. They'll say, do you want to keep running script on this? You'll just say no, 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 no. And then I'm going to paste in here that URL and click go. And so that should bring up kind of a randomly chosen quote from founding fathers, Thomas Jefferson, 1782, legitimate powers of government, et cetera, et cetera, et cetera. And I'm glad to just import the whole entire page here. So I'll just click import. Oh, and I think the instructions tell us where to put it. And I think it's just A1 on the, I think we're supposed to name the sheet as well. Let's go, we'll go check and make sure. But I'm going to put it in let me go just check over standby. Yeah, bring in A1, name the worksheet quotes. So I'm going to say, okay, that should bring it in. So now here I have this. See if I can make this wrap. Alignment, wrap text. The instructions say to change the name of the sheet to quotes. And the whole point is that was not an import process, that's a query, which means if I come up here to where it says refresh all on my data tab, if I do that, it will make another request to that web server. It'll say, hey, what's on that page? And it's asking for the same page. And because this particular page just chooses a random quote, it will change each time you refresh it. But the idea is that you've got some data there that updates from time to time, and you need to be able to go and get what the current data is. So we can just refresh and we can see we've got a web query. Okay, questions? Ultimately, we're going to be automating this, right? So we'll have code that is going to say, all right, let's change the URL that we're looking at, bring in the new data, copy it, put it somewhere and so forth. But for today, it's just we built a web query. Once we've got that, here's how you submit. We'll come back to the Atlas tab. I'll click on the submit button. It's going to ask me for my credentials. These are my educators, how I log into my educator. Oops, it knows I'm the professor, gives me some other choices here. I'll just go ahead and submit it. And then that should bring up my score here on my educator. I got 10 out of 10, 100%. I feel pretty good about that. Okay, but that's the process. Usually it'll be more involved than just make a web query and submit, but that's the idea. You make sure you've got the Atlas add-in loaded, you download the assignment file, then you should be able to get the instructions, and then you'll be able to do your work and then submit right through that same tab. All right, show me on a scale of 0 to 5, 5 meaning I totally got it, 0, I'm clueless about this. How are you feeling about the process of submitting homework? 555555555. Thank you. All right. So most days in this class, we will be doing quite a bit of coding. So sometimes the examples, what we're going over, it'll be like, all right, we're going to kind of do kind of a useful, today in class, we'll build something that might actually be useful to you, even when we're done with class. And we'll use that as a context to be able to show whatever it is I'm teaching about. Other times it'll be like lots of little snippets as I'm demonstrating lots of different things that don't really fit together. Occasionally it'll be mostly lecture, like maybe this and one other day. And so, but that's today. So not a whole lot of coding. We will do some examples and we'll see this, but you're probably just as good off to watch the examples as you are to type them, although you're certainly welcome to type, follow along. So this is getting us introduced to kind of a fundamental concept in programming, the idea of a variable and a constant. I just show of hands, who was saying, I totally already got this. Variables, I got it down from some of the language. So it looks like about half, maybe not quite half. And even those of you who think you've got this, I think you pay attention, you'll learn some things about ways variables are implemented that you probably hadn't known in the past. Okay, so in the physical hardware of the machine, there is one place that I can store a value, let it sit around for a while, and then call that back, readily call that back to be able to do something on it. Well, you've got the hard disk where you can store it for long term, but in terms of a place where I've got kind of ready access to be able to go and say, hey, what was that value? And bring it back in and work with it and set it aside again and call it back in. What is that place called in the physical hardware of the machine? The place where I can store a value, yeah. That's RAM, yeah, random access memory. This is what it looks like. Here's a memory chip, and right in here, somewhere inside this chip, we want to be able to store some information. It's volatile, which means that as soon as we lose power, it all goes away. But that's what we're doing here. Inside that chip, we're going to think about lots and lots and lots of little values that we can turn on and off, ones and zeros. Ultimately, with my computer, everything that gets stored and saved and worked with has to be able to be represented as a series of ones and zeros. And so our challenge is to be able to say, gosh, how are we going to say, I want to kind of look at this part of memory right here, and I want to say, yeah, what's in that part and be able to bring it back. How do I even talk about, how do I refer to where that is? And how do I say, yeah, that's the place I'm interested in seeing what value is there. And so this is where we have the idea of a variable. So there's kind of lots of things that kind of tell us what a variable is. So a variable is a location in memory. Now, think about all that memory that we've got out there. It's a particular location and that has a name. So it's a location in memory that has a name where a value of a particular type can be stored and retrieved. So I've got a location in memory that has given it a name, and there's kind of some other characteristics, but the whole idea is that I'm going to use the name of that variable. It's like a nickname for that location in memory to be able to refer to that spot in memory. So memory, of course, is all ones and zeros, but the smallest unit of memory that we're going to address in our language here, VBA, is going to be a byte. We don't do anything that's smaller than a byte. Byte is 8 bits. A bit, what does the term bit even mean? It's just short. It's a concatenation, a shortened concatenation, a contraction of 2 words. What is it? Yeah, binary digit. So a bit is just 1, 1, or 0, but we're going to work with 8 of them at once. And so the smallest unit we'll address is referred to as a byte. So just some lingo to get here. So if we think about, we've got this byte, these 8 different bits. Here's how we store a number. So if we say those are all zeros, then what we've done here is we've expressed the quantity 0, the number 0. This is going to be binary notation for us. And so this column is going to represent how many ones are in it. This is going to represent how many 2s, how many 4s, and so forth. So we just basically say wherever there's a 1, we add the column value that it has, and that's what's going to give us the value. So I look here, say we've got 1, 1, the value is 1. If I go here, we say I've got no ones, I've got a 2, I have 1, 2, so the value is that we've expressed here is 2. Which kind of brings us up to the old joke. There are that number of types of people in the world, those who understand binary and those who don't, right? Because that's how you represent the quantity. What is that number in binary? That's 2. It says there are two types of people in the world, those who understand binary and those who don't. When I was looking for this image, I came across another version of it. There are two types of people in the world, those who understand binary and those who have friends, which I thought was kind of clever as well. Okay, so 3, it's a 2, it's a 1, that's the quantity 3. That's what 4 looks like, just only 1 4, nothing else, and so forth. Okay, so what's this one? Oh, 65. And so that's, now, kind of quick question, am I going to ever test you on this? Where I'm going to say, all right, here's a binary number, and what is it going to, what is it by? No. So this is just kind of background, to get understanding about how variables work. We'll be testing you about variables, yeah. Like what's the best kind of variable to use for this kind of data and that kind of stuff. But in terms of actually, how it's implemented, that's not what we're headed. That's not where we're headed here. All right, how much? What's this one? Yeah, someone can hit that so fast. So to get 255, what did you do? Did you take 128 plus 64 plus 32 plus 16, all those, and then add them up? What'd you do? Yeah, it's just the next in this pattern, right? This squares every time, and so, or doubles every time. And so what's the double of this? 256. And so, if I was to go 1 higher, that'd be 256. But this is then 1 less than that. Because of course, if I said I'm trying to, if I had another bit out there and I said I'm trying to add 1, just add 1 to this, well, we'd have to carry the 1, 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 carry the 1. It would finally push over to be 256. So this is just 1 less than 256. But that's another way to get at it is just add up all those values. Okay, questions so far? We've actually looked at our first data type. I guess, okay, we'll talk about the first data type here in just a second. So what if we had 2 bytes instead of just 1 byte? So now now we're showing 256, right? So we've gone over to that next level higher. And you think, what does that mean? Now that I'm using twice as much memory, I should be able to store twice as many values? And the answer is no, it's way more than twice because every additional digit is going to double the capacity that we have. So, ooh, what is that? My guess is that's 1,000. I don't remember from these slides. Yeah, that's 1,000. I mean, I guess I must have remembered because how else would you get there, but I wasn't sure. So yeah, 256 plus 512 plus all those, ends us up at 1,000. Okay. So then this is our first data type. We actually have a data type. Now remember, a variable is a location in memory with a name of a particular type. And so the type for the variable is important to us. So let's just go ahead and take a look at declaring a variable of this type. And insert a module. And again, you're welcome to follow along. I'm not sure that you get a lot out of following along, but if you wanted to follow along, I'm gonna do that a little slower. Alt F11 will bring up my Visual Basic Editor. I'm gonna insert a module. That'll give me a place to work with my code. And that should bring this up. Now, maybe you remember from our last little experience of recording a macro, the keywords we have here are sub and end sub. But a sub, I'm going to give it a name. So this is a sub procedure. I'm going to give it a name of var demo. All right, so now I can actually work inside of this. So here's how I do it. The keyword to declare a variable is dim. It is an abbreviation of dimension. We are setting the size of the amount of memory that we're using. That's kind of where the word comes from. I was looking at, reading somewhere and someone said DIM stands for declare in memory. No, it doesn't. It's short for dimension. I'm not sure that that's important, whatever, but that's how we declare a variable. We then give it a name. So maybe I'll call this no, employee number. And then I will give it a type as byte. So when you declare a variable, use the keyword dim, you give it a name. The name can be, it can only include letters, numbers, and the underscore character, and it's got to start with a letter. So no spaces allowed or whatever. And then you say as, and you give it the type byte. So this then just allocates how much memory. It allocates 1 byte, so 8 bits of memory. It's the smallest one that we do. So I can now, the whole point here is I can now put a variable in, a value into this. Emp no equals 100. Let me do this, debug dot print emp no. So debug dot print is just going to allow me to see the immediate, see this results in this thing called the immediate window. Your immediate window you can get to by choosing view immediate window right here. Control G brings it up. I'm not sure what the keystroke is in Mac. But the point is when I call this, little review from last time we were together, an object-oriented language. And so often what we're going to see is we're going to see object dot and then either a property or a method. Someone tell me the difference between a property and a method. Object is a thing, property and method then are characteristics of the object that we're really interested in. Someone tell me what one of those is. What's you say, a method is, or a property is. Yeah, so method's an action that the object knows how to do, right on. A property or an attribute, which just a value that describes the way the object is. And so in this case, what do you think this is? Property or method? Yeah, it's a method. We are telling the debug object to print something. And what are we going to tell it to print? Whatever emp no is. So I'm going to go ahead and run this just by clicking on the green play button here. And it we'll get to this line. It will say, ask the operating system, hey, I need some memory. I need a byte of memory. The operating system says, great, here's some memory that no one's using. It's all yours now. We'll make sure no one else tries to look at it or whatever. And gives it up to Excel. We'll say we're putting a value in it, and then we're printing the value. But the key here is that when I say print emp no, it doesn't actually print the characters emp and o. It says, oh, I understand that. That's a variable. I know what that is. When you say this, you want me to go and look at the location in memory that I'm remembering with this name and getting that value and printing the value that's stored in memory at that location. Okay, questions here?
What's the debug part of it?
So the debug is just one of the objects we have available. So one of the objects we have available is like a range. Like we could say active cell dot value. So in this case, I'm talking about a different object. And now I'm using a property, not a method. And I'm going to say that is equal to emp no. And so this now will be an assignment statement. Say, look in that location in memory, pull the value out, put it into this property of this object. So in this case, when I run it, it will print it up here as well, but it's going to print, it's going to put 100 over here in whatever the active cell is. So this is just a different object that we haven't played with before today, and we're calling a method of that object. And the whole purpose of this is for while we're in development mode, while we're developing, just to be able to say, I'd like to be able to see what's the value of that variable or something. I want to be able to see it right here in the immediate window. All debug.print does is print the immediate window. There's another method. There's only two methods for the debug object. One is called assert, and the truth is I don't even know what assert does. I kind of played with it once but couldn't figure it out. But debug.print is the main thing that we do with it, and that's just to put a value right up here in the immediate window. Incidentally, it's called the immediate window because it lets you immediately execute a line of code. So it's not just a place to receive the output. It's like a command line interface. I could say active cell.value equals 99999, and that would execute that statement and put that value into the active cell. So yeah, we print stuff to it, but then you can actually, it's kind of nice because you're thinking, I wonder what this statement would do. You can just kind of come in there and play with it. Okay, let's go ahead and come back to our discussion on variables. So that is the first data type byte. I can only put integers in. Now there's going to be a limitation on how big of an integer I can put in. What's the limitation? I only have 8 bits. So what's going to be the valid range that I could store? Yep. Yeah, 0, which is all zeros, and then kind of any other variation of ones and zeros until I have all ones, and that's going to be 255. So if I try to put something too big in there, it won't go. In fact, let's suppose I had that full of all ones. It is completely full of ones, and I tried to push another one in there. What would happen? Suppose I had a cup that was completely full water, and I tried to put more water into it, what would happen? It would overflow. Oddly enough, it would overflow. And actually, that's exactly what the lingo is here. Let me try to put in here 255, and we'll run this. Runs just fine. I'm going to try to put in 256. I'll run that, and I'll get an error that says overflow. Until you understand what's going on in memory, that there's no room to put any more numbers in there, overflow makes absolutely no sense as an error message. It's a terrible error message. When they made the language, they're really trying to make the language, to be as accessible as possible. They gave almost no thought to what the error messages were. Okay, but now you understand why it's overflow. Well, what happens? What's the lowest value? 0. So I put 0 in here. That should work okay. What if I put -1? What do you think? Is it going to underflow? No, it's still going to overflow. Overflow means you're trying to put a value into the variable that it just can't take, just can't accommodate. All right. So if we have 2 bytes, then so this is the next data type. We got a data type called integer. Now, first of all, a byte is an integer. It's a single byte integer. Right? I can only put integer values. I can't put 1.2. What happens if I try to put 1.2? What do you think? You might, that's a pretty good answer. You might think, hey, this isn't going to overflow. You can't fit 1.2 in there. But let me go ahead and do it. Let me do 5.4. And we'll run that code. And interestingly, it is not going to fail. So it's a reasonable thing to think, hey, you tried to put something here into memory that wouldn't fit. We're not going to let you do it. The philosophy of VBA when they're making the language is they say, listen, we want to be as accommodating to kind of beginning programmers as we can. And so instead of failing, we're going to try to come the closest that we can do it. And so in this case, I tried to put in 5.4. It said, you know what? I can't fit 5.4. What's the best I can do? I'll round it. 5. I would try to put 5.5. I think it would round to 6, wouldn't it? I mean, isn't that how it should round? Remember rounding like in 3rd grade when you learned about rounding? Yeah, that one's going to round up. So it's going to do its best. And that's one of the things that makes kind of experienced programmers from other languages really uncomfortable with VBA, is because you think, you know what? I tried to put 5.4 in there. Don't be putting something that I didn't tell you to put in to memory. You should stop and tell me to do it right. And that's not the philosophy of VBA. There's going to be lots of times where it's going to guess at what you meant. And hopefully the guess will be right. All right, so when I declare a variable, I choose a name, right? I dim empno as a particular type. Now, the operating system, then VBA, the VBA interpreter talks to the operating system and says, hey, I need 1 byte of memory. The operating system says, great, I got all kinds of memory that's not being used. And I guess I'm showing here the stuff in gray is not used. The stuff in blue is, kind of in use by some other program. I got 1 set of memory that everyone has to share. And so kind of on an individual basis, these different programs say, hey, I need a little more memory. The operating system says, here's some that no one else is using, and we'll allocate it to you. And then part of what the operating system has to do is to say, no one else is allowed to read or write that data. Right? That now belongs to Excel. We don't want R changing it. We don't want Word changing it. We don't want Microsoft Internet Explorer changing it. Once that's ours, it's ours. And in fact, in the really early days of Windows, it was really common to have what's called a general protection fault. You were kind of working along, and all of a sudden Windows would just stop, and you'd get a GPF error, general protection fault, which meant that some program tried to allocate memory that it was not allowed to have access to. And back then, in the early days of Windows, instead of just preventing that from happening to that application, it stopped everything. I mean, it stopped the operating system. It was terrible. It did teach us to save quite often, but it was unusual to go a day without like a general protection fault in the early days of Windows. Oh, nightmare. Anyway, but now it says, all right, the operating system says, great, I'm going to give you this memory. Now, if I'm declaring a byte, that's the address of that bit right there. That 1 right there is at this address. That's which number I got. By the way, how many bits do you have on your computer? Do you know? How many bits do you have in memory? How many bytes do you have? Sorry, how many megabytes do you have? probably 8, 16, kind of the newer computers now are starting to come out with 32 megabytes. So how do you get to a megabyte? So you've got 8 bits as a byte. You got 1024 bytes is a kilobyte. 1024 kilobytes is a megabyte. 1024 megabytes is a gigabyte. Okay, so it's like scaling by factors of 1,000 kind of each time you go to the next level. So you've got millions and millions of these. And so this is the, what is it, 4, there's 3, that's 100,000, that's millions. That's the 3 billionth, that's the 3 billionth bit right there. 307 or 3 billion, 176 million, et cetera. And that's the next one over, right? That's just the next one. They all have an address. We often think about memory addresses not in decimal, just their kind of ordinal position, but we'll use hexadecimal. So this is base 16. Because base 16, because the base is the power of 2, it's kind of nice for working, kind of converting between binary and base 16. So you very rarely see memory addresses shown in decimal. You'll see them more often shown in base 16 hexadecimal or octal, which is base 8. Not that that's important, but the point is that it's got some address that we're glad we don't have to keep track of. Because what happens is the operating system says, here's the address. VBA interpreter, here's the address of the memory you asked for. I just allocated 1 byte for you and it starts at this address. And the VBA interpreter then makes the connection between the memory address that we're able to work with and the variable name that we gave it. So when we say empno, the interpreter goes, I got it. You're talking about that location in memory. That is, this particular location in memory. Are you glad that you don't have to think about these in terms of their actual addresses? Yeah, you should be really glad about that. And the point is, the important point is that we don't care where it is. It'd be really bad if we said we want some memory and that's the memory we want, because in a world where we have multiple programs running at the same time, what happens if I say I want that, but someone else wants that particular bit or that particular byte? So works out really well. The program, in this case, the VBA interpreter, asks for some memory, and then the operating system says this memory belongs to you, then it keeps track of the address for us. Okay. Whew. So when we say dim x as integer, there are the 16 bits, the 2 bytes that we're getting, and those will be at a particular location in memory. And then that's what the VBA interpreter is going to remember. It's going to remember that the name is x, it's at that location in memory, and it's 2 bytes. It keeps track of that for me. All I have to do is think about it as x. Okay, questions? Okay, so how are we going to do a negative value? Can I do a negative value in the variable type byte? No, 0 to 255 is the range. Here's what it does. To do a negative value, it says, all right, we're going to store an integer. Same way we do with byte, we'll store an integer, but instead of starting to count at 0, we're going to start counting at some really far negative number, usually about halfway through what our range is going to be. So if I were to look at this byte, this integer, so what I actually have stored here in terms of the actual value is 1,000. So 512 plus 256 plus 128 plus whatever, it comes out to 1,000. But even though that's the absolute value that I have stored in memory, it's not 1,000, because what the Visual Basic interpreter does for me is it looks in memory and says, you've stored 1,000 there. That's not how we count for this data type. This data type starts counting. Oh, that was really interesting. I wonder how I did that. This data type, integer, starts counting at negative 32,768. That's the starting place. And so when we have 1,000 stored as the integer, we add it on to its starting point, and this value then is actually negative 31,768. So that's how we get to a negative value. We don't really store a negative value, we store only integers, but according to the data type, then it says, all right, I can tell you what this is because we don't start counting at 0 for integer type. We do start counting at 0 for byte. There's no negative number for byte. But for integer, you can go as low as negative 32,768. Okay, So here is the value stored, 32,767. So what is that for an integer, if I've actually stored that value? Well, start at the low, count up, and that's going to give me -1. That's what -1 actually looks like. So that's the next one higher. That's what 0 looks like. Just 1 in the 32,768 place. And we add that on, and that's going to give us 0. Because anything that doesn't have, let's see, anything that doesn't have a 1, do I have a laser pointer here? That doesn't have a 1 right there is going to be negative. And anything that has a 1, I guess I should point with the mouse so folks on Zoom can see it. Anything that does have a 1 in here is going to be 0 or higher. This bit right here is sometimes referred to as the sign bit. Because if you look just at this particular bit, you could know, is it negative or is it 0 or more? So this is the one that's going to tell us a little bit about sign. So there's a term sign bit. We don't really talk about it in VBA, but just kind of a general computing lingo. Okay, so there's 0. We're storing 33,768, and so that's how we store 1,000. And you realize that this looks just exactly like 1,000 looked before, plus it has the sign bit flipped over to be a positive number instead of negative. If we've stored the quantity 65,563, everything full up, well, that's -32,000 plus that is going to give us positive 32,767. So the integer data type takes 2 bytes, and the range is, that's the range. And that's why that's the range. Now, I'm going to expect you to know something about the range for these different data types. I am not going to expect you to know that it's 32,768 to 32,767, but I would expect you to know integer type, yeah, that's roughly plus or minus 32,000. So yeah, to be able to use the data types well, you've got to know something about that. So you can expect, something on the midterm examination to see, do you know that if I try to put something that's 35,000, negative 35,000, integer is not going to do it because it's out of range. Okay, how are we doing? Just kind of show me a scale of 0 to 5. How are you feeling so far? 5 being fantastic. Seeing some 3s, 5s, thank you. Okay, our third type of storing integers is called long. The type is actually long, it's short for long integer. And so instead of 2 bytes, which is what you have for a integer data type, this one's 4 bytes, which gives you this range, roughly plus or minus 2 billion. And you have precision, right down to the ones. Okay, but certainly we're going to have to store decimal values. Can we store decimal values in any of those first 3 data types, long, integer, or byte? The answer is no, but it is possible to store integer values, as you might have guessed. And so how do we do it? There's a couple of options. We have 2 different data types. Well, 2 that are kind of fundamentally different, and then some other categories of it. So one is to say, look, just store the integer, and the data type, the variable is just going to know O is divided by 10,000 to give us 4 decimal points of precision. And so that's the first type. So if I imagine this, I'm storing this value. I think our smallest, that's called a fixed point number. I think our smallest one, is 4 bytes. Maybe it's even 8 bytes. I'm not sure. So, but if I were doing this scheme with 2 bytes, if I stored that number, I would say, okay, great. I've got 65,000. I'm going to divide that by 10,000, which is going to give me those 4 decimal points of precision. So the idea is I just store an integer, but then the interpreter knows, oh, based on the data type, when I read that integer, I'm going to convert it, to a decimal by doing this to it. Okay, so that is referred to as a fixed point number. Here's another example: 52,000 divided by 1,000. That's 5.25. So, oh no, it is smallest. This is the smallest fixed point we have is 8. It's 8 bytes. It's called currency. So you can dim, amount due as currency, and that says, okay, we're going to store information this way. So I always store to 4 decimal points of precision. So if I just put a whole number into it, it'll store it with 0, with 4 zeros past the decimal point. What if I try to store something that's got 10 decimal points of precision? What's going to happen? Based on what we've seen so far, what do you think? It's going to round. Yeah, it's going to say, well, you know, we can't be that precise that you're asking, so we're going to round it and we'll move on without even letting you know that we're doing it. Okay, so the other option here, instead of having what we call a fixed decimal number, we have something called a floating decimal number. And so the idea behind a fixed decimal number is we're storing an integer, and we always know there's 4 decimal points, there's 4 digits past the decimal point. This one says we're going to store an integer, but we're going to use some of our memory that we're storing to keep track of where the decimal goes. So if we said those 4 bits that we have up there in green, we're going to say we're going to use that part to keep track of where the decimal is. And so we don't use those 4 for figuring out what the integer value is. So in this case, we have 3,574 stored. And how many digits are to the left of the decimal point? Based on what we have up here in green, how many digits are to the left of the decimal point? 0. So that really is what value we're storing. But if we were to say we have 1 digit past the decimal point, then it's 357.4. If we say no, there's 2 digits past the decimal point, it's 35.74. 3 decimal points. What if there's 15 decimal points to the right? Then it's this really, really small number. And so the idea here is to say we're going to use part of the memory to store an integer that tells me where the decimal goes, and another part that tells me what the what the digits are that we're storing. So this is what we call a floating point number. Questions? All right, so we've got 2 floating point decimals, data types. One is called single. Stands for single precision floating point number. It takes 4 bytes, and it is, you know, that's my range, but it's only precise to 7 significant digits. So I can do really, really big numbers, but they can't be really, really precise. You know, I can get to, you know, numbers that are, you know, 7 places of precision. That just means it can't be very big because all that's happening past the decimal point. So I guess let's just pop back over and declare one of these. So now if we were to dim emp no as single, it should be able to take 5.6 and handle it just fine. 5.6, a bunch of decimal points. It shouldn't be able to do that, but it should do some rounding for me. And it's rounded to that level. Another data type that we have is called a double precision floating point number. I don't even know how you say that number, but that's your range. But again, you're only precise to 15 significant digits. So you can store up to 15 digits, and then you can push the decimal point way out far in either direction. So you can be really, really precise, you can be really, really big, but your significant numbers are only 15. So those are the 2 types of floating point numbers that you'll want to be familiar with, single and double. It turns out that the actual implementation is a little more complex, and I've simplified it here a little bit, but that'll give you a good feeling for how it goes. All right, well, how do we do true and false? We've got another data type. We use true and false values all the time. So this one's kind of a little bit interesting and not especially intuitive. So we're going to store 0 to mean false, and we're going to store -1 to mean true. You might think, well, maybe 1 should be true. And the truth is, if you're looking at a number and you're asking, is it true or false? The way it's going to work is that if the number is 0, it's false. If it's any other number, it's true. But the actual way that true is stored is as -1. I'll show you why. So in this case, and it actually uses 2 bytes for this. That seems crazy. I could store true false values using a bit. I mean, if I could get down to a bit, it would only take 1 bit. But it seems like for sure I should be able to do it with a byte. But in VBA, it's going to be 2 bytes. Why? Yeah, why does it use 2 bytes? And the answer is because it's going to go to a negative number, and it's kind of bootstrapping off of the smallest integer type that can handle negative numbers. And there's a real reason why it does why it wants to use negative numbers. We'll get here in just a second. So if this were an integer, what value would that be? That was a scratch. I thought you were volunteering. Yeah, I remember the integer starts at negative 32,768, and I've got 32,768, and so that's 0. And so this is how we would store false. Well, what then does -1 look like? It's just like the opposite of this, right? So it is, just change all of those. And so this is -1, and that then is how we store true. And it turns out that when we're saying, oh, listen, we've got to deal with this down at the memory level, flipping all the bits is crazy easy to do and blazingly fast. And doing any other value to be able to store that as true besides -1 is going to be not as efficient. How much difference are we talking about in efficiency? You're talking about nanoseconds of difference, right? But if you're, and realize this is a thing that it does all the time, that kind of thing is going to add up. And so they're using the most efficient way they can to be able to manipulate true and false values. And so that's why -1 is true, is because it is exactly opposite of 0. And flipping them all is easy, kind of like the easiest thing we can do. Okay, so that data type is called Boolean. That's a great word, Boolean. Boolean, maybe it makes sense. Named after a guy named George Boole, who was an 18th century mathematician who spent his career thinking about values that are true and false, and how do they compose and how do they work together. And so there's a whole field of mathematics called Boolean logic that's named after this guy. And the range is true or false. That's really all it is. Okay, how do we represent a date? We have a data type called date. So we could come in here and dim higher date as a date. Let's see, where's my shift key? Now, every data type has a default value. In many programming languages, when you say, give me some memory, it says, you want the memory? Here it is. And what's going to be in that memory? A bunch of 1s and 0s. Well, what are those 1s and 0s from? They're from whatever was last used in that location in memory. And so, if you don't initialize your in some languages, if you don't initialize your variables and say this variable is going to start at 1, what's it starting at? Who knows? Wherever it used to be. I mean, wherever that memory happened to be. But in VBA, they said, that sounds like a reason to get lots of support calls about why things aren't working quite right. And so part of what happens when we declare a variable in VBA is it says we're going to give it a default value. All numeric variables default to 0. So if you're going to guess, since all numerics default to 0, what would you think would be the default for Boolean, true or false? Yeah, false, because 0 is going to be the default. Date is going to have a default value as well. Shall we see what it is? This should show us the default value for date. Oh, it's just giving us a time. Let me add 1 onto it. Let me say, I'm going to increment higher date by 1. I'm yelling at it. Higher date equals what it used to be plus 1. And so this is what, and when you add 1 to a date, it's going to add 1 day. So what's the default value? What's the default day for a date type? No, I added a day. I didn't subtract a day. I added a day. December 30th, 1899. What? Yeah, I don't know why that's what it is, but I don't know why that's what it is. So, but again, now what we're doing is we're going to be storing the number of days before or after, depending on if the number is positive or negative, from an initial date, which in this case is December 30th, 1899. Now, the truth is there's some kind of a date bug in Excel. Any of you familiar with the date bug in Excel? It's like things are off by 1 day under certain conditions, and I'm not sure when they fixed it or what. but my guess is it has to do with them accidentally choosing December 30th instead of thinking they were on December 31st or something, because December 31st, 1899 seems like a reasonable place to start, but December 30th doesn't. Okay, so in this case, we've stored the integer value 27,945. So what day is that? It's like 27,000 days after December 30th, 1899, which happens to be July 4th, 1976. So that's how we do dates. So how do we do a date and a time? And the answer is, instead of just storing an integer, we are storing a fraction. And so we're going to get the number of days plus the portion of the next day. So in this case, we're going to say some starting date plus some number of days plus some fraction of a day. So 0.375 of a day is going to get me from midnight, the very first instant of a day, up to 9 a.m. And so that's how it is. And in fact, if I was to take that value, 27,958, 27,958, what was it, 0.375? Then that's going to be, oh no, 717. Oh, I'm off in my math for this slide. Anyway, that's giving us at 9 a.m. on a particular day. That's that many days from the beginning of time. Questions? So that's how dates are stored. Oh, by the way, did that seem like a strange thing to do? Because, right, the underlying value for a date is numeric. So I can plug a number in and it goes, that's not a date, but I get it. You know, I can convert that into a date and it does the conversion for us. But ultimately, in fact, it's easy to do because it doesn't have to do any conversion at all. It just stores the number that we get. Oh, okay. So far we've dealt with numbers, some variation of numbers. Dates, maybe those aren't really numbers, but you see how we do dates. Okay, so now how do we do characters? And the answer is each character is going to be mapped to a value between 0 and 255. So we'll look at a particular value here and we'll say, 65 is A. So that's how an A gets stored. It takes 1 byte per character to store a character, to store a collection of characters. However many characters we have, it takes that many bytes because each one is going to be a byte, right? Because if we filled that whole thing up with ones, it would be 255. All the way empty is 0, and that's going to be my range. So I've got only that number of characters to work with. Now, can we do more than 255 characters? Yeah, we do all kinds of strange characters from foreign languages and so forth. And that will take more than 1 byte per character. And that's not the real simple implementation, but we're just getting started here with this, the way string is implemented in VBA. Okay, so I'm just going to take that same thing and kind of turn it up on its side. So I've got an A there, and then I've got the rest of Adams, John here. And so what we'll see here is that the first byte that I've turned up vertically is 65. The next one, lowercase d, is 100. Lowercase a is 97, and so forth. And so this is like what the memory would look like to store the string of characters, Adams, space, John. Now, kind of an interesting thing is you'll say, space is itself a character. And which character is it? Space is number 32. So you want to store a space, it's a character like any other character. It happens to be number 32. And so this is called the ASCII code, the American Standard Code for Information Exchange. And what we'll see, there is 65. Over here at 32 is space. What else did we see? Lowercase a was 97. And so those are all just right here. So no problem. VBA is going to just store this. So the VBA interpreter is going to store this as numbers. But because the data type is string, it says when it reads those numbers out of memory, it says, okay, I got to use the ASCII table to convert them into characters and display the characters on the screen. Questions here? Might be interesting to notice that these first 32 characters, 0 through 31, are all non-printable characters. And this actually goes back to the, oh boy, have you seen like a movie from the 1970s that may have like a newsroom in it? So you've got, people here in this newsroom, There's all this kind of chattering that's kind of going on in the background, kind of just like typewriters going crazy. Those aren't typewriters. Those are what we call teletype machines, which is basically you say we are sending kind of character by character across a phone line, and we'll be sending it, from Montreal, where our correspondent is, into the newsroom in New York. And those teletype machines are just actually typing out the characters. And we are sending the characters then kind of in this order. So if I want to send an A, I send 65. But when I want to send a backspace, I would send number 8. And that would just tell the physical hardware of the machine to move the print head back 1. Kind of an unusual thing to do, but you have that. This one just amazes me that's here. Audible bell. Like you could print 7 to it and it would ring the bell on that printing device. If you wanted to advance the paper, you would send it a 10, and that would give it a line feed. If you wanted to send the carriage head back to start printing again, you'd send it 13. If you send it a 13 but didn't send it a 10, it would send the carriage head back. It wouldn't advance the paper, and it would write the next line right over the top of it. And so that's kind of where this system originates. Most of these below 32, we don't use anymore. We still use line feed, carriage return to kind of indicate the end of a line. We still use backspace to indicate backspace. I don't know anyone uses the audible bell, or vertical tab, like 30 and 31. No, where's vertical tab? 11 is a vertical tab, yeah, line feed and so forth. Okay, now, as it turns out, all the data types we've talked about up to this point have been what we refer to as fixed length data types. When you allocate a variable, when you say I need a variable that's an integer, you're getting 2 bytes. And if you need to store a larger number, you are out of luck. It doesn't change the size. String, how much you store determines how much you need. And so for the first time, we have now a variable length data type, which means how much memory actually gets allocated when I declare it, just a small amount to indicate how long it is. So in addition to the 1 byte per character that we need to store the actual string we're working with, now we've got 4 bytes of overhead. The 4 bytes of overhead tell us how long the string is. So this string is, how long is this string? If I look over here in this first column, I've got 8 plus 2 plus 1, 9, 10, 11. That's 11 characters. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this first part, the overhead part says this variable is 11 characters long. And so we start at this location. The first 4 bytes just tell me the length. And then the next, in this case, next 11 bytes are going to tell me what we actually have stored. And so when okay, we'll get to the memory here in just a second. So this is the data type string, and it is plus or minus, well, it's 4 bytes plus the number of characters. And there's a limit. In fact, there's a limit to how long the string can be, because if I fill this portion here all up with 1s, that's going to be some number, and that's the biggest one that I can do. I can't specify a string any larger than that. How big is it? If I fill all with 1s, how long is my string? Can my string be? And the answer is it can be 4 gigabytes. So a string variable can be really pretty big. 4 gigabytes is, if we're talking about text, it's big. How big is the full text of the Book of Mormon? I don't know why you would know this. It's about 1.5 megabytes. And so in a string, you can hold like 3,000 copies of the Book of Mormon in one string variable. Okay, so you can get big. Okay, so here's what happens is that we say, all right, we're declaring a variable as a string. And so remember that we bind the name of the variable, which in this case is name. The name of the variable is name, which is not the best choice I could have made for this one. But we bind the name of this variable onto a particular address. Because it's a string, then we know that just by declaring it, we allocate 4 bytes. And those 4 bytes are going to be all zeros. So Is that 32? That might be exactly 4. Presumably that's exactly 4 bytes. So, but we'll come along and we're going to say, now we want to put something in it. We want to put John Adams into that string. Can we just increase this string to be able to hold the next 11 characters? Gray background here means it's in use by some other program. Can we just increase it? No, there's not room. Well, we got 1 more byte there. And so we can't just increase it. And so when we say name equals John Adams, VBA says, hey, look, operating system, we're going to need now, I know we told you before we needed 4 bytes. We don't need those 4 bytes anymore. We now need, what is it, 15? Is it 11 plus 4 bytes? We now need 15 bytes to be able to store this. And the operating system says, oh, great, here's a new place for you to store that string, and we'll give you then that block allocated. And then we store in the first 4 bytes, we store the part that says how long we are, 11 bytes. And then we got the 4 bytes plus the next 11 bytes. And that then is allocated to say John Adams. Which means that every time we change the value of a string, it has to find a new place in memory to put it. Even if we're not changing the length, it's going to find a new place in memory to put it, which is a little bit inefficient. Okay, questions? Um, 15 bytes. All right, we got another data type called object. What we've talked about so far, date, currency, long, single, string, these are all what we refer to as primitive data types. They're just values. There's a new type that kind of comes into a gray area, and this one is called object. Now, if we think about a particular range, here's range A2. The range A2 is complex. It's got lots of properties. The object itself doesn't have the methods. It's the object class that keeps track of the methods. We don't have extra copies of the select method here in this particular object, but we do have to have memory allocated for every property that we have to store. And so this range is sitting somewhere in memory, and it's complex. It has an address, it has a formula, it has a value, it has a column, it has a row. It's got a list as long as your arm of all these different properties. It's got a font, it's got an interior, it's got a background color, it's got a pattern that goes on the cell, it's got the color of the pattern of the background of the cell. These are all different properties. And so that's sitting up, taking a good size of memory to be able to store the information for that one cell. Now, how are we going to refer to that particular, how are we going to refer to that range? We've seen a couple of ways to refer to a range. Looks like I've gotten rid of it. So one was to say, and we're going to have a whole day where we talk about different ways to refer to ranges. But one, if my active cell happens to be on A2, then I can refer to that range by saying active cell. I'll just come here and do it in the immediate window. Come on. Active cell dot address. ACTIVEC, active cell dot address. Tells me it's A2. That's great. Active cell dot value. Okay, so that's one way to refer to a range. Another way is like this. Just put it in square brackets and put it right in there. I was absolutely blown away the first time I saw that. It's really weird compared to how you do everything else in VBA. Another way you could say range, and then in quotes, A2. Give us the same thing. We could say cells, A2. So row number 2, column number 1 will tell us the same thing. But by the way, in this particular workbook, how many cells do I have that the address is A2? How many cells have the address A2 in this workbook that we're showing right here? More than one. There's one on every sheet in the workbook. And this one has 2 sheets. It's got one called query, one called sheet 2. And so I might need to say, oh, sheet 1 dot cells. And that's actually the underlying name, but I can go for the name on the tab by saying sheets query dot cells. Oh, it's quotes, thank you. Oh, but I might have more than one workbook open. Workbooks number 1. Workbooks number 1, subscript out of range. It's not 0 based. What's the name of my workbook? That's a long name. Okay, we'll do active workbook. That's got a book. It turns out I could have more than one instance of Excel open, and I could have to tell which instance I want. The way I get to the instance that I'm currently running on is called application. And so it could be, depending on what I'm trying to get at, it can be a really long string to reference down to which version or which instance of Excel, which workbook, which sheet, which cell that I'm after. And so the idea for, but that range, that range is stored in memory at a location. That range starts at an address, just the same way the string starts at an address. There's a location where it is. What a range object is a range object then allows me to, an object variable, sub obj, that'll be fine. Let me call it RNG as an object. This is going to allocate just enough memory for me to keep track of another location in memory. Because this right up to this point right here is referring to an object, I can now say set RNG equal to that object. And this is because this is at a location in memory somewhere, I can now bind on this variable to that location in memory, and this now becomes a nickname for that range. I can now do debug.print RNG dot address value. And that should print Thomas Jefferson for me. So what we have here then, this is what's called an object variable. This is pretty complex, right? But this is just holding enough memory to keep track of where something else is in memory. Last thing here is that it's not just object. I can get specific about the kind of object. I can dim it as a range. It's still an object variable doing exactly the same thing, but now the only kind of variable this thing is allowed to bind onto is a range. It can't bind onto a worksheet or a chart or an element of a chart or a workbook. Object can bind onto anything. This now can only bind onto a range. So now if I run that, we'll get Thomas, if I run the right one, we'll get Thomas Jefferson again. Okay, we're gonna spend some more time on the variable type for object. Okay, questions? Hopefully that's the last lecture, so severely lecture. And we'll get hands-on next time we get together. Thanks for coming. Class dismissed. Yeah.
I have I tried with the Atlas. For some reason, it's not working.
Can you come up to my office?
Yeah.
Yeah, come on up. I mean, yeah. Hello.
If I can get next. Okay.
Let me see though if I can make it so you can follow along on your Mac. Because what we're going to do with it next time, we'll have to do some right at the very beginning. But then if I give you something to download, you'll be able to follow the rest of it. I'll see if I can get that going.
I mean, I do have a Microsoft like next topic.
Yeah.
But I can't read that selection.
Hello. Yeah. Wait, actually, let me get myself on off this machine because there's other class right after this. Variables in the 2022. I've got to get that file uploaded. Oh, the video already goes to the cloud, so that's okay.